Okay, the next question is, we've got 10 parking lots. We must give space for 6 teachers and a principal. 4 of these parking lots have shade, which the principal always gets one of those, and the other 6 will get the other 9 parking lots. Okay, this is a combinatorics problem. So for this type of problem, we have to find a way to systematically list all the possibilities. And to list all these possibilities, usually you have to start with one piece of information and see how many ways there are to do that. So we've got 10 parking lots, and what we could do is look at all the number of ways to pick 7 of these parking lots, and then after that we can look at all the ways we could give the principal one of those parking lots, and then all the ways to give the other 6 people one of those parking lots. That will be very difficult, because when you select these 7 parking lots, there can be many possibilities. We could have picked just 1 parking lot with shade, we could have picked 2 parking lots with shade, 3 parking lots with shade, or 4 parking lots with shade, which would affect the final calculation. We'll basically have to break it up into many cases. So that's not the way to go about it. Another way we could go about it is, I only see one more way, which is I see 2 more ways, but let's just go to the answer. Another way to go about it is we take the 4 parking lots and we give one of those to the principal, and we see how many ways there are to do that. Namely, they are going to just be 4. And then what we do is we take the remaining 9 parking lots and give them to the 6 other teachers. Okay. In my mind, I always have to make sure, am I considering every single case, and am I considering every single case exactly once? So in my mind, I create a sort of list of all the possibilities, and I check whether every possibility just occurs once. Now, we give the principal one of the 4 spots. So I've got this massive list of all the possibilities, and I break it up into 4 sub-lists, where the principal has the first spot, then another list where the principal has the second spot, third spot, and 4th spot. And clearly these 4 lists will be different, because each one iterates with the principal having a different spot. Then I say, okay, there are 9 spots left. I take the first teacher and I give him one of the 9 spots. And what they'll do is we'll break this list up into a sub list with 9 different possibilities. And everything is symmetrical here, so in this case we'll also break it up into a sub list with 9 possibilities, and in this case we'll also break it up into sub lists with 9. So what we're going to have here is, eventually, unless there's something weird goes on, we're going to have 4 times by 9. Then in each of these sub lists over here, I then look at what's the possibilities for the next teacher. And for the next teacher, there will be 8 spots left, and that will create 8 sub lists where the teacher gets one of the spots. And everything is symmetrical, so all of these lists will be broken up into 8. So we'll have 4 times 9 times 8. Then for the next teacher, I would have to take this list, break it up into 7 sub-lists, each one of these lists over here. Then let's see, this is 3 teachers so far. Then we'll get the next teacher, which would be breaking it up into 6, and the next teacher, which would be breaking up into 5, 1, 2, 3. Next teacher breaking up into 4 sub-lists. So the number of entries in this long list is just 4 times by 9 times by 8 times 7 times 6 times 5 times by 4. This is a multiple choice question, so I don't actually have to calculate this, I just have to approximate it. This over here is approximately 8 cubed. This over here is, well, we've got 20 times by 24, which is 480. 8 cubed is about 500. This over here is also about 500. So multiplying this together, we get a number very close to that. Okay, to solve in a question like the 12, we just have to express this in terms of equations. So we've got, let's call this side length x, and let's call this side length y. Then we have got that the length of CG is 9. So this is a square, so this will also be y. This over here is also a square. This over here is 9, so using Pythagoras we get x squared plus y squared is 81. Then the area of the shaded region is 49 squared, so that is just going to be x squared minus y squared is 47, sorry, not 49, 47. And then the question asks, calculate the perimeter of the shaded region. Well, the perimeter is just going to be 4x. So all I have to do is calculate what is the value of x. Adding these together, we get that 2x squared is, let's see, that is 8. 1 to 8, therefore x is just going to be 8, and therefore 4x is just going to be 32.